Hello, year three. I hope that all of you are healthy and safe. Today we are going to recheck our homework together. Please concentrate as much as possible. I'm going to explain each question. And if you have any confusion, please repeat this video as much as you can so you can get the right answer. Our unit, which is the last topic about forces in motion. And we said the forces mainly represented in either pushes or pulls. So in question number one, in the first page of your homework, in your workbook, page 68, question number one, ask you that you have to write whether the action in front of you in the pictures is a push or a pull or both. Okay? In picture A, he told you that the boy is mixing some ingredients to make a cake. What do you think he's going to make with the flour and the eggs and the sugar and so on? He must push the ingredient to mix them well. In question B, he told you that he's greasing the tin. Greasing the tin means he started to place some butter. To place some butter, he must push to place the butter in the tin or in the pot. In picture C, he told you that he started to put the cake mix into a tin. What do you think he's going to make to put the mix of the cake in the tin? He must push the mix to be placed inside the tin. In picture D, he told you that he's going to put the cake in the oven. What he's going to make to put the cake in the oven, he's going to push the tin inside the oven. Okay, because the door of the oven is already open, you will not pull the door. He asked you that he's going to put the cake in the oven. So to put the cake in the oven, he must push the tin he's holding. In question E, he told you that he started to cut the cake. What do you think if your parent hold a knife and started to cut the cake into pieces? They must push on the cake so they can cut it into pieces. In picture F, he told you that he lifted a slice onto a plate. If your mom going to lift a slice of a cake into a plate, she must pull this slice and place it in the plate. So picture C will be pull. Question 2. He asked you to draw or label some of actions you are doing in the morning to show the forces you use. You may write whatever you think during you may write whatever you think what you are doing during the morning. I just chose 3 things. We mainly do it when we get up at early morning, like that. At first, you are going to push the covers off you. When you are in the bed, you're going to push the bed cover so you can get up. Second thing, I think that you're going to pull a comb through your hair to brush up your hair. So you're going to pull a comb through your hair. And then you're going to change your pajama and wear on your clothes. So you're going to push and pull clothes into your body. To wear on, you are going to pull, and to wear off, you are going to push the clothes. So you are going to push and pull clothes into your body. If you think about other than those actions, it's okay. But you have to concise to the point of the forces. What you are going to push or pull. You have to state that you push something or pull something. Those are just an examples. You can imagine what you have to write in this question. Second page, page 69. Question number 1, he showed you 2 students pushing the box in opposite directions. One stand on the left and the other stand on the right. And he asked you if the box is going to move. If those both children push it with the same force in opposite direction, and you have to state why. What do you think? Imagine that there is a box and you start to push it with the same force against your parent or your sibling. What do you think? If you push in the same force, the box will not move, because the box to move need a force. So the box will not move because the force is the same. Both children push with the same force in opposite direction. In question B, he asks you to draw what will happen to the box if both children push it from the same side. If they both stand in the same side, what's going to happen to the box if they started to push? And he asks you to draw an arrow to show the direction of the push force. If they stand in this side, they are going to push forward so they can move their box. If you, in another word, if you place the students or the children in this side, in the left side, so you have to draw the arrow in this direction because they are going to push to this direction. So the arrow will depend into the place where the children stand. If they stand here, you have to draw the arrow pushing to this direction. Okay? Question 2. Below are some pictures of children moving boxes on a shiny wooden floor. They place it in a shiny wooden floor, which of course would be a smooth floor. Okay? He asks you to draw and explain what will happen to each box. If, in question A, the push force is bigger, if the man is pushing this box with a big force, if he push harder, he's going to move the box to the further distance. So as I draw here, I place the box at the end of the picture because the box will move further or will move for a longer distance because the man is pushing in a bigger force. Question B told you the box is lighter. It's a light box. What do you think? Will the box move or not? Imagine that you are moving a small box. Will it move on a smooth surface or not? Of course, it's going to move because it will need less force. It will be easier to move. If I make the box more light, I will not need more force to move it. On the contrary, I'm going to need less force to move it. So if the box is lighter, become more light, it will be easier to move as it will need less force to move it. I don't need to push hard because it's a light box. In question C, told you that another child is sitting on the box. What do you think? If the box will be heavy or light? If someone sits on a box and you try to push this box, are you going to apply a small force or a large force? Of course, you are going to exert a very large force because it's a heavy box. That's why I drew the box in the beginning of the picture, because we will need more force to move the box as it will be heavier. I'm going to apply very large force to move this box because it's heavy, because someone is sitting on the box. Please, if you have any confusion concerning the questions, repeat the video as much as you can until you understand easily. In page 71, here he's speaking about force meter. Do you remember what's a force meter? Force meter, we said it's a device which we use to measure the force pulling down an object. And we said that force meter consists of a spring and a hook where we are going to place the object. When we place the object, there will be a force pulling down. Do you remember what's the name of this force? Which is discovered by Isaac Newton? Yes, it's gravity. The gravity or the force is going to pull the object down, and so the spring will move, and I'm going to know the force meter reading. Okay? But we said that it's very important to use the suitable force meter. I cannot use a force meter for a small force meter for a large object. It's going to apply a large force. because my force meter is going to break down. And I can't use a very large force meter for a little object because I'm going to take an inaccurate result because the spring will not move freely. Okay? In this question A, he give you some force meters and ask you to sort them, which is better for the following masses. For example, the first force meter is yellow one, which can hold an object up to 5 kilometers or 50 newtons. So the yellow force meter can hold up an object up to 5 kilometers, while the beige one can hold an object up to 1 kilometer. The blue force meter going to hold up an object up to 250 grams, while the red one is going to hold an object up to 2 kilograms, while the green force meter is going to hold an object up to 500 grams. In the following box, he placed some objects and placed their mass in kilograms and grams and told you to sort the force meters according to their color. So you have to have a look on each force meter and how much he can stand the force, or how much he can stand an object in kilometers, in kilograms or grams. Okay? For example, the first object is a large book. He mentioned that it weighs 489 grams. You have to check the scales. The yellow one will be suitable? No, the yellow one is going to carry till 5 kilograms. But my book is just 489 grams. So while searching in these force meters, you're going to find that the green one is the suitable one because it's hold an object up to 500 grams. So this one will be the suitable one for holding the large book. Okay, the next one, pencil case. The pencil case, he told you that it's only 35 grams. What do you think? Which one will be suitable for measuring this mass? Do you think the yellow one of the 5 kilograms, or the beige one of the 1 kilogram, or the blue one of 250 grams, or the red one of the 2 kilograms, or the green one for 500 grams? Yes, of course it will be the blue one, because the blue one holds up to 250 grams, which is suitable for 35 grams. Concerning the child chair and the brick, the child chair is 900 grams and brick is 1 kilogram. Do you know that 1 kilogram consists of 1,000 grams? Very well. So children's chair is 900 grams and the brick is 1 kilogram. Which force meter will be the suitable one? Yes, of course, the beige one will be the most suitable because it holds up to 1 kilogram. So the child chair and the brick is going to be pulled by the beige force meter. The next one, the musical case. The musical case is about 210 grams. What do you think? Yes, the blue force meter will be the suitable one because its range is up to 250 grams. So we are going to write blue. What about the lunchbox? Lunchbox weighs 450 grams. Which force meter would be suitable? Which can stand the force of 450 grams? Yes, the green one, because its range is up to 500 grams. So we are going to write green. What do you think about the school bag, which is full of books? He said it's going to weigh 850 grams. 850 grams, which is less than 1 kilogram. Because as we said that 1 kilogram is equal to 1,000 grams. So which one can afford less than 1 kilogram? Yes, the blue force meter, the beige force meter, sorry. The beige force meter is going to withstand the mass of 850 grams. What do you think about a full shopping bag? It's very heavy, it's about 3 kilograms. Which force meter can withstand this amount? We just have one, which is the yellow one. The yellow one can stand force up to 5 kilograms. So we are going to write yellow for the shopping bag, which is full of stuff. Okay. Question B. He asked you in question B, which object has the biggest force? And as we said before, that the force is something that pulls the object down, and the force affects the mass, because the mass is the amount of matter inside an object. So which one would have the biggest force? Of course, the object which will have the largest or the biggest mass. So the answer will be full shopping bag. Question C. Which object has the smallest force? Smallest force means it's going to have the smallest mass. As shown in the table, of course, it would be the pencil case. It just weighs 35 grams. Question D asks you, why would a beige force meter, the beige one, which can hold up to 1 kilogram, is unsuitable for measuring the shopping bag? Because as we said before, if we place a very big force on a small force meter, it's going to break down. And that's why the shopping bag weighs 3 kilograms, while the beige force meter just stands for 1 kilogram only. So it will break down. And the answer will be because it's for objects up to 1 kilogram, and the shopping bag is 3 kilograms. Well done. Page 72. Question number 1. There are 2 students which are playing the bubbles. I think that most of you like the game of blowing bubbles. They need to investigate how the change of the size and the movement of the bubble using push and pull force. Would you imagine that I have a bubble game? What are you going to do to blow a bubble? You're going to place the stick in the soapy water, and then you are going to push the air in the stick, or you are going to blow the air in the stick. So you are going to have a bubble. In question A, he asked you which force could they use to make the bubble move along the air. What are you going to do to move your bubble in the air? Yes, of course, you are going to push or blow air in the bubble so it can move in the air. Question B asks you which force could they use to change the direction of the bubbles. They wanted to move the direction of the bubbles from right to left and left to right and avoid it from going down on the floor. What they are going to do? They must blow air from different directions. They must blow air from left and right and then right and left so they can keep their bubble blow in the air or move in the air. So in question B, they must push or blow air from different directions. They must blow air from different directions. Okay. Question C. He asked you what could they do to change the speed of the bubble. Do you want the bubble to move very quickly or very slowly? How they are going to change the speed? What do you think? Yes, if you blow harder, you are going to push the bubbles very fast. But if you blow softer, they are going to push the bubble for a small distance and the speed will be decreased. So, if they want to change the speed of the bubble, they must blow harder or softer. If they wanted to move them very quickly, they are going to blow hard. If they wanted to move them very slowly, they are going to blow softly. Okay, question D. Which force could they use to stop the bubble from hitting the floor? They don't want their bubbles to be popped up. What they are going to do? What are you going to do to avoid your bubble from popping up? Yes, you are going to push air upward. You are going to stand on your knee and start to push by blowing air upward. So you can send your bubbles upward to avoid hitting the floor. Question E. Which force could they use to pop the bubbles? What they are going to do to pop the bubble. If you wanted to pop up your bubble, what are you going to do? Yes, of course. I know that you are going to push with your finger so your bubble will pop up. So the force could they use to pop the bubbles, they must push their fingers on the bubble so the bubble will pop up. Okay. Question 2. In question 2 in this picture, they ask you to draw an arrow to show the direction of the force needed to make the bubble move. And you have to add push or pull to show the type of the force. If you want your bubble to move, what are you going to do? Of course, you are going to push. Imagine here is the bubble. And here is the girl blowing air. What do you think? The arrow should be in this direction to represent the pushing because she's blowing air and push the bubble away from her. So please take care of the direction of the arrow. It should be in the same direction of the applying force. Question 3, sorry. Question 3 asks you to write true or false for each sentence. Question 8. Forces can make bubbles change direction. What do you think? After you see the investigation of the children, what do you think? Yes, of course. Force can change the bubble direction very easily. If they started to blow from right to left and left to right, the bubble is going to change its direction. Okay, question B. A pulling force makes the bubble move. You can pull a bubble? Of course, no. So the force that makes bubble move is the pushing force, not the pulling force. Question C. The bigger the force, the more the bubble will move. If I blow more air, the bubble will move more and go to a further distance. So the answer will be true. Question D. A push force makes bubble move forward. As you see in this picture, she push or blow air, so the bubble move straight forward. So in question D, the answer will be true because a push force is going to make the bubble move forward, straight forward. Okay, question E. A pull force would make bubble move backwards, agile. Do you think she can pull the bubble? I don't think so. It will be so hard. She can only push the bubble, but if she tries to pull the bubble will pop up. Question F. A smaller force would make smaller bubble. If you blow slowly or softly, you're going to have a small bubble. Yes, as we said before, if you blow hard, you're going to have a large bubble and it will move in a fast speed. But if you blow softly, you make a small bubble which is going to move for a short distance. Very well. Next page, page 47. Friction of shoes. He asks you to write in front of each question if this object is going to have a high friction or low friction. Let's see together. What do you think about a ballet shoes? Ballet shoes should have a low friction so the ballerina can move and dance easily. She can slip on the floor and do its movement easily. So ballet shoes need to have low friction. But what do you think about a sports shoes? Someone need to run and make some movements. He must have a high friction to avoid slipping down so he can grip easily in the floor. What do you think about flip-flops? Flip-flops, these flip-flops that you use on the beach. Flip-flops have low friction. That's why when your legs start to become wet from the beach, you start to feel slippery. So flip-flops have low friction. What do you think about a running shoes with the spikes? Did you know the base of the shoes? It has spikes, same as football shoes. They have a rough soles, so they can grip the player in the ground and can't be slippered easily. So the running shoes with the spikes and the football boots must have high friction to avoid the slipping down or the floor to be slippery for the player. Okay, question 2. In question 2, you have a bar chart which show how high of a slope needed for a shoes to move. Imagine that you have something like slide. This is a slope. And you stand here wearing those shoes, hiking boots, sport shoes, flip-flops, ballet shoes. And he told you that he's going to measure the height of the slope, this level, okay, needed to make a shoe move. The hiking boot needs 30 centimeters because it has high friction. So they are going to move for a long distance. But the ballet shoes just need 5 centimeters because it's very smooth and have low friction. So it just needs 5 centimeters to move on the slope. However, in this question, he asked you to suggest, in this question, he just asked you to suggest some ideas of writing a question for this bar chart. Let's think together. What is the question you may ask from these data presented? You have many types of shoes and the slope and a distance. So the first question could be, which shoe moved at the highest or the lowest height of the slope? Which shoe is going to move from the highest point of the slope, or which shoe moved at the lowest height of the slope? But if you need to make it more difficult question, you may use friction. And you may ask in another way, which shoe had the best grip? Which shoe is going to grip in the floor and need a high slope to move? While in question C, he asks you to write more and more difficult question. By another word, in another words, he asks you to speak about friction. Imagine you have a hiking boots which has high friction. By the way, hiking boots are the boots used in climbing the mountain. Some say hiking and some say hiking, both are right, it's okay. So hiking boots or hiking boots are used to climb mountains. So they must be so rough, so they would have high friction, so the man who's climbing the mountain don't slip down, okay? So we may think in another question, which is, which shoe has the highest friction? What do you think? Of course, hiking boots have the highest friction, while the ballet shoes have the lowest friction. Okay. Anyhow, I know it's a difficult question. Question number 2, it's a difficult question and need to make more activities and more investigation. I promise that when we return back to the school and start this topic one more time, I'm going to let you make many and many activities concerning friction and forces. But right now, I need you to have some brainstorming and to know more about pull and push and friction. Very well. Next page, page 57. We have question number 1 only. It has the same idea of the past questions. It just needs you to identify which object has high friction and which has a low friction. What do you think about the slide? Do you think the slide needs to have a high friction so you can't enjoy your playing? Of course, no. The slide must have low friction so you can slide easily. What about racing car tire? Do you know that racing car tire move in a very, very high speed so they can win the race? So of course they need low friction so they can move very quickly and to win the race. So racing car tires have low friction. On the contrary of our cars, our modern cars we use in the streets have high friction to avoid the slippery or slipping down during the rainy days. But racing cars need a low friction tires so they can move in a very high speed during the race. What do you think about ice rink? Here is someone make skating. Of course, he needs low friction so he can move easily on the snow. Okay, woolen gloves, of course, they will have a high friction because they are rough surface. What do you think about banana skin? Did you see any time during watching your cartoon someone throw a banana skin and the other one coming backward to him and come slippery in the floor? Yes, banana skin is slippery because it has low friction. Trolley cart or shopping cart, as we said in our study note, it must have low friction so we can move a heavy object during shopping without feeling tired. But what about training shoes or a running track? What do you think? Shall they be with low friction? Of course not, because it will make many problems and difficulties for the trainer to use them. The trainer shoes must have high friction, while the running track must have high friction to increase gripping in the floor. So the trainer could move and run as fast as he can without slipping down and to grip very well in the floor. Okay, next page, page 78. In page 78, we have many boxes with different weight, and we are going to answer the question, but we have to look very carefully on the boxes. He's going to ask you some questions about friction, and he told you that these boxes have different mass. For example, box A is heavy, box B is light, box C is very light, box D is very heavy, box E is empty. It contains nothing. Okay? Let's see question, the first bullet. Which boxes are the easiest to move? What do you think? Of course, the lightest boxes are going to move easily, like box B, which is light, and box C, which is very light, and box E, which is empty. Why they are the easiest to move? Of course, because they are the lightest. They don't need much force to be moved. They need very little force to move because they have a very small mass. Okay. Next question, he asks you which boxes are the most difficult to move. Yes, of course, box D and box A. Why? Because they are the heaviest. One is heavy and the other is very heavy. So they need much and much force to move from place to another. Okay, what do you think, which box has the highest friction? Well done. Box D is going to have the highest friction because it's very heavy and it needs a very large force to move, and that's why it's going to have a high friction. So bullet 3, box D has the most friction because it's very heavy. Okay, question number 2, ask you to circle the sentence to complete it. If they are moving the boxes on carpet, wow, what do you think about the carpet? Is it a rough or smooth surface? Yes, carpets are rough surface, and that's why they have high friction. As we said before, the rough surface has high friction, while smooth surface has low friction. So if they are moving the boxes on a carpet, the friction will be higher, of course, than on shiny wooden floor, because shiny wooden floor is very smooth. Question B, the very heavy box is difficult or easy to move on a carpet? Think that you have a heavy box in your living room in the carpet, on the carpet. What do you think? Can you move it easily? Of course not, because there will be a very high friction force. So the very heavy box is difficult to move on a carpet because the carpet is rough, so the friction is high. Okay, question 3. Jamila and Croy thought about how to push very heavy box. They need some idea to help them to move the heavy box easily on the carpet. They suggested 3 sentences, and he asked you to choose which 2 sentences are the best to reduce the friction. Which 2 options are going to help them to move the box easily? The first option, they said, get more children to help to push the box. The second option, use a skateboard and use the skateboard underneath the box to move it along. The third sentence, make the carpet very slippery by using oil. What do you think? Which of those sentences are more logic to be done to reduce the friction? Would they get more children to help to push the box? Yes, of course. If they are going to find more children to push the box, they are going to have more force. And more force means that more pushing force, so they can push the box easily. What do you think about using a skateboard underneath the box to move it along? Yes, it's a very good idea. Do you know why? Because as we said before, the wheels reduce friction, and skateboard has wheels. When they place the box over it, it will act like the shopping trolley. We place a heavy object inside it, and it has a low friction, so it moves easily. What do you think about making the carpet very slippery by using oil? Can they place oil on the carpet? Will be logic? Of course not. How they are going to place oil on a carpet? So the 2 answers would be the best to reduce the friction is getting more children to help to push the box, or to use a skateboard underneath the box to move it along. Why those are the best? Because they are going to reduce the friction and increase the pushing force. That's why they are going to move the box very easily. Thank you so much, grade 3, for your concentration. I hope that you enjoyed the session. Please, if you have any confusion concerning the questions, repeat the video as much as you can, and repeat the illustrated video of the explanation. And you may use your study note, of course. You may search on the internet for pull and pushing courses on YouTube Kids. It will be very interesting. Use many sources, and you're going to find that this topic is very, very entertaining. Thank you so much. Please study well, recap your post-study notes, as you're going to have an assessment. See you later next session. Thank you so much. Goodbye.